everyone, and welcome to Xiao Classroom. In this section, we introduce the use of simple series PLCs to implement a configuration operation as a Modbus TCP Master. First, right-click on the device and select Add Device. Then select the Ethernet adapter under Fieldbus and click Add. Then click Add Ethernet. Select Modbus TCP Client in the right window and add. Then select Modbus TCP Client and add Modbus slaves under it. You can add a few slaves if you need them. The name of the slaves can be set by yourself. If so, I will add a slave as an example to demonstrate. Let's take a look at how to configure parameters. First of all, on the Ethernet side, we can choose the network interface card for Ethernet communication. Click here to browse, and then we can see all the network ports on the PLC. We generally use the O network port for Ethernet communication. Without using EtherCAT communication, the IP1 port can also be used for Ethernet communication. Select it 0 and click OK. If you want to change the IP of the PLC, you can also tick the following content after the settings are completed here. When you log in and download, your modified IP will take effect. If you don't need to change it, you don't need to tick it here. Then let's take a look at the configuration of the main station. Double-click the master to open its properties interface. You can set the timeout time and check automatic reconnect. Then the configuration of the slave. Double-click the slave to open its property configuration interface. On the general side, you can set the IP, timeout time, and port number of the slave station. We will use a debugging assistant for the demonstration later. So the slave IP is the IP of the computer. Then the port number of the slave station here is consistent with the actual slave station. Then add the variable address for data interaction between the master and slave in the Modbus slave channel. Click below to add a channel, and you can set the channel name yourself. There are a variety of function codes to choose from here, and different function codes can realize read and write operations on different area parameters of the slave station. For example, you can use the function code of writing a single register or the function code of reading and holding registers. Here, we will simply configure a few channels to read the hold register and coil of the slave station. For demonstration, then there are 3 types of triggers below. One is the periodic cycle triggering method. This triggering method only needs to set a cycle time here, and you can automatically access the slave every cycle according to the time we set. If you choose the rising edge trigger type, a rising edge variable will appear in the channel of the low mapping interface. Every time you want to access this channel, you need to re-trigger the rising edge variable. The application trigger type is similar to the rising edge trigger type. But if the application triggers, we need to call the Modbus channel function block in the program and then access the channel. It is similar to the rising edge trigger type, both of which can be artificially controlled to read and write access to the channel. The 3 trigger types here will be demonstrated to show you the specific operation. First, set channel 0 to cycle trigger mode and set a cycle time. The O3 selected by the function code is the read and hold register, and the offset of the hold register and the data length are below. Set the length of reading 5 words here. Then you can set whether to clear the channel data to 0 or keep the last value when an error occurs. Click OK after the configuration is completed. If you need to access other parameters, continue to add channels. Channel 1 is set here to read 5 consecutive coils, with slave offset address 0 triggered by rising edge. Then add a channel configured to be triggered by the application to write to 5 consecutive holding registers of length with slave offset 16 number 10. Simply configure 3 channels to do the demonstration. This is the channel initialization configuration. On this interface, the function of initially assigning the corresponding register of the slave when establishing communication for the first time can be realized. Under this setting, assign 10 to 20 consecutive addresses starting from 0 in the slave holding register offset. Then here is the slave parameter we just configured. One thing to note is the unit ID here. The default value is 255 for devices that use a network port to serial port. The serial port address of the device needs to be the configuration of the unit ID here is the same. For pure network port devices, the unit ID is invalid and only needs to be corresponded when it comes to serial port devices. Then the channels we just configured will appear in the I/O map. And you can also see the rising edge trigger variable corresponding to channel 1. When we want to access channel 1, we trigger it by giving the rising edge variable a rising edge signal. Then channel 2 is triggered by the application. We need to access it through the function block Modbus channel in the program. So we call the Modbus channel command in the block before using it. Just write the name of the slave station directly from the station side. Then here is the channel trigger variable. Then this is our channel index, consistent with the channel index of the slave application trigger type. After the configuration is complete, each time the variable x1 is triggered, an access to the channel to parameters can be realized. Let's use the Modbus Slave Debugging Assistant to do a slave coordination demonstration. Let's download this program first. At present, we can see that both the master station and the Ethernet port are good. The green circle shows that its status is normal, but the slave station shows a triangle, indicating that the slave station and the master station have not communicated successfully. We open the Slave Debugging Assistant and set the communication parameters. The unit ID and the unit ID set by the slave station can be kept the same. Then first select the retention memory area, which is 20 in length. Then configure the communication protocol and communication parameters under the connection. Port number 502, because the debugging assistant is used. The slave IP is the computer IP. Then if you choose to ignore the setting of the unit ID here, pay attention to the communication status on the left. When the master and slave establish communication, it will become a green circle, and the value we just configured in the initialization channel will be written in. We can also synchronize the data transfer in the I/O map. It should also be noted here that if the variables in the I/O map are not used in the program, we need to switch the call bus before we can monitor the data in the I/O map. You can see that the data in channel 0 is updated periodically in real time. It should be noted here that when the master station writes the value to the slave station, the channel I/O map cannot be written, but it is possible to assign the value in the program, which will not affect normal use. Then let's take a look at channel 2 again. The operation of writing multiple holding registers is triggered by the application, so the variable will not be passed to the slave after being written. You need to trigger the X1 variable on the Modbus channel instruction before you can pass the data. After triggering X1, you can see that the data is successfully passed to the slave. Finally, let's take a look at the coil reading again, because the debugging assistant can only display one area at a time. So let's delete the master's access to the hold register before looking at the coil reading. Change the slave data area to coil. Because channel 1 is a rising edge trigger type, the master station cannot read it after the coil state of the slave station changes. You need to trigger the rising edge trigger variable corresponding to channel 1. The above is the simple series PLC through the configuration of the PLC as Modbus TCP Master operation demonstration. Thanks for watching.